Welcome to video lecture number 5 for solutions. In this video, we are going to cover how to make a solution, both from a solid, chemical, and a liquid one. Now, unfortunately, we won't be able to do this because we aren't in school, but I'm still going to go over the basics of it in case you ever pure assist for the science department or take advanced chemistry. You will need to know this stuff. So to start with, this is a volumetric flask. Now normally we don't use glassware to measure in because it is not accurate unless you are using a graduated cylinder, right? We don't use flasks, regular Erlenmeyer flasks or beakers to measure in because they just aren't accurate. Volumetric flasks are different. They are extremely accurate. So if you see there's a kind of a thin white line on the neck of that volumetric flask, you see that this is a 250 milliliter volumetric flask. So if you were to fill that flask up to that thin white line, you would have exactly 250 milliliters of solution. And then it also comes with a glass cap that you see on the top there that is used to obviously keep the liquid in. And the only way to mix a solution once it's in the volumetric flask is really to just invert it, because if you were to swirl it, that liquid isn't going anywhere. So that is a volumetric flask. These come in different sizes from 100 milliliters up to 1000 milliliters and everything in between. So depending on how much solution you need, you'd pick the correct volumetric flask. Now when you're using a liquid stock solution to make a new solution, most of the time you will use a glass pipette to measure instead of a graduated cylinder, because glass pipettes are a lot more accurate than graduated cylinders are, but glass pipettes only come in very specific volumes. So like this one here is a 25 milliliter. If you look at the image of that glass pipette, the full image, right above where that bubble is, it says 25 milliliters, there is a blue line. If you fill this glass pipette up to that blue line, it'll be almost exactly 25 milliliters. Now the issue with these, I hate using these because they are a little difficult. You usually use a red rubber bulb like you see in the upper left-hand corner. That goes on the top and you basically suck up the solution past that blue line. And then you have to quickly take that rubber stopper off and replace the top with your thumb so that you don't lose solution, right? If you just take the rubber stopper off, the solution just starts draining out of the pipette. You want your thumb immediately to go on there so that the solution stays above that blue line, and then you carefully lift your thumb off the top to allow solution to drain out of the bottom until it gets exactly to that blue line. If you were to have the solution go beneath that blue line, you would have to start over, putting that rubber stopper back on, sucking up more solution, replacing with your thumb, and getting it exactly to that blue line. They also make some easier devices that can replace the rubber stopper. That's the blue, green, and red devices you see on the screen. These are plastic, and you stick the white tip onto the top of the pipette, and then there's like that rolly part at the other end of it. You roll that and it sucks up liquid, and it sucks it up pretty slowly so that you can get it to stop right at that blue line, and then you would just release into the next container and all the solution would drain out of it. However, these plastic devices are very specific. So for instance, I believe the blue one only sucks up about 10 milliliters. So if you only have a blue one, but you have a 25 milliliter glass pipette, you can't use it. So let's get into how to make a solution. We are going to start by making a solution from a solid solute. So what you would do is you would take a volumetric flask that is the size that you want your final solution to be. You put in the weighted amount of solute into the bottom, and then you would use distilled water to fill it up about halfway. Now the reason you fill it up halfway and not all the way at first is because if you only fill it up halfway, when you swirl that, it actually allows the solute to mix in with your solvent to start making that solution. And then once it's as dissolved as it's going to get, then you take that wash bottle again and you add enough solvent to get up to that volume marker or the calibration mark of the volumetric flask. Then to make sure everything is mixed correctly, you would put that cap on and invert it to make sure that everything is mixed, and then that's your solution. If you have to start with a liquid solution, like a stock solution, you would use your glass pipette to measure out how much of that stock solution you need. You'd put that into your volumetric flask. You'd add a little bit of water, swirl it around to mix, and then add more water until you get up to that calibration mark. And then again, you'd put the cap on, invert it to mix everything, and you should have your solution. So let's say I ask you to make a solution. I need 500 milliliters of a 2.0 molar silver nitrate solution. How would we make this solution? So we would first have to figure out how many moles of solute I would need to measure out in order to make this solution, right? I'm given liters of solution, and I'm given molarity, so I could use those to figure out the moles of silver nitrate that I need to measure out first. However, remember that our electronic balances measure in grams. So really, I would have to calculate how many grams of silver nitrate I would need by using that molarity equation to find moles, and then using a mole conversion to find grams. Then I would measure out that amount of silver nitrate, add it to my 500 milliliter volumetric flask, because that's the total volume I want, so that's the flask I would use. Then I would add about 250 milliliters of distilled water. Doesn't really matter how much, there's no way to really measure it accurately, so just fill it halfway, and then you would mix it. And then you'd fill it all the way to the 500 milliliter mark with that same distilled water, put the cap on, and then mix it, and that would give you 500 milliliters of a 2.0 molar silver nitrate solution from a solid solute. So let's say instead that I need 100 milliliters of a 0.1 molar hydrochloric acid solution, but I have on hand a stock solution that is 12.1 molar. How would you make this needed solution for me? Obviously, the first step is going to be to calculate how many milliliters of that 12.1 molar stock solution you would need to measure out using that glass pipette. You would then measure that out, add that to a volumetric flask that holds a volume of 100 milliliters because that's the total volume I want. Then I would fill that 100 milliliter volumetric flask about halfway with distilled water, swirl to mix, and then fill it all the way up to that calibration mark, put the cap on, and mix it completely. Then I would have 100 milliliters of a 0.1 molar hydrochloric acid solution. That's going to be it for video lecture number, whatever number we're on, 5.